And large language models suffer from something called hallucination, which means they make things up because they're using probabilistic techniques to work out the next most logical word in a sequence, and that may or may not be correct. So all language models suffer from hallucination, and there is a percentage probability that everything you get from it might be wrong.
Welcome to the CUDOS Cast. I'm your host, CUDO Pete, and I'm pleased and proud to be back. We have a fantastic guest for you today. He is the CTO of AI for HPE. It's Matt Armstrong-Barnes. Yeah, I've been looking forward to this one for a few weeks, so I'm really pleased that we've got to the day, and here we are to discuss all things AI. Welcome to the show. Matt, how are you today?
Yes, very good. Thank you. How are you?
I'm really, really good. Thank you very much. Yeah, our community has been saying for a while, come on, where's the next CUDOS Cast? Where's the next CUDOS Cast? So I've been keen to get a really good guest on. Yeah, we'd love to learn a little bit more about you, but the reason why I was so keen to get you on is because I heard you speak at a HPE event not so long ago in London, and just the way you were explaining things, I thought it was just fascinating, and huge buzz around AI now, and I think what would be really useful is to kind of demystify some of the terminology, but also explain the kind of differences between different types of AI as well. So on that note, Matt, if you would like to introduce yourself, a bit of your background, what you've been up to, what you're seeing, all of that lovely stuff would be really good.
Yeah, cool. Yeah, so Matt Armstrong-Barnes. So I'm the HPE Chief Technologist for Artificial Intelligence. So from my perspective, I've been in role for nearly 7 years now. So I've seen quite a lot of evolution in the space. Been in HPE for coming up 11 years. I've been in the industry for a bit longer than that. You probably can't tell. I've got 1 or 2 grey hairs coming. So for me, I cover the entire HPE portfolio in the AI space, right the way through from the compute, storage, networking, up into the software layers in terms of how you accelerate AI initiatives, and also the services engagements. And I do work directly with customers on their AI initiatives, helping build AI strategies, all of those kind of things. So for me, AI has been going on an absolutely incredible journey. It only ever seems to get more and more associated with it, and just the hype around it's at an all-time high, I think that, and then in 2 months later the hype gets even bigger. So keen to demystify a little bit, explain what some of the hype means, some of the terms, and really how you can get practical about getting involved and getting AI initiatives off the ground.
Brilliant. But before we go on, actually, just on that hype, because I think we've all seen the diagram, right, with the curve, and it's the top of the hype, and then there's a bubble, and then it bursts, and then it goes into that kind of trough of disillusionment, and then it starts to grow again as technology gets adopted. And we've seen that across all new technologies in the past as well. But AI to me somehow feels different, and as a technologist yourself that is deep in that for one of the biggest vendors in the world, does it feel different to you as well? AI as a technology, do you feel like it's going to follow that same kind of hype as others, or is there more substance to this one?
So I think if you view AI, the term artificial intelligence was coined actually in the 1950s, and it's been through what are termed as a number of summers and a number of winters. So there have been times in the 1980s where there was huge hype around AI. That sort of died off again, then it's resurged, then it died off again. So we're sort of in the Game of Thrones, and I think summer is coming. It's been here for a while. So 7 years ago, when I first started to sort of became 100% dedicated to only working on AI initiatives, I spent a lot of time explaining what it was. How that's evolved is from trying to convince organizations they need to start thinking about bringing AI into their organization, to really now, which is everyone's asking the question, why don't I have something from an AI perspective in my organization? How can I get accelerated? The more mature customers I'm talking to, it's all about scale. They've got some small initiatives that they've got running, but now they want to go big with them. And the very more mature organizations, it's all about sustainability, because we know that this technology consumes enormous amounts of power. Power generates heat, which we need to cool. So the role of, from a technology perspective, is about how we bring the technology in, how we make it sustainable, and ultimately how all organizations can get benefit from it. So definitely I think the key breakthroughs that have happened have been in the original maths created in the 1940s, 1950s, meeting GPU acceleration, which probably happened about 2012. There was some key breakthroughs, so more than 12 years ago. And the GPU acceleration that we're seeing is just increasing, meaning that we're able to do more expansive things with AI. And then some of the key breakthroughs that have happened in the generative AI perspective, which really have captured everybody's imagination.
And is it generative AI? And I'll ask you to explain what the difference is in a moment, because I think that's an important distinction for us all to understand. But do you think it's the kind of Gen AI, the ChatGPT effect, if you like, that really has kicked off the excitement? And from what you just said, now why there's that kind of more of that pull effect where these businesses are coming to you instead of you going to them and saying, what are we going to do to get this implemented, rather than you saying you need to implement this?
Absolutely. I think ChatGPT, the biggest number of users in the shortest period of time, everybody's using it. It's really captured everybody's imagination. And a lot of organizations have been using artificial intelligence techniques for quite a while, but they're now starting to use sort of the more advanced ones, which again do require significant amount of computational power. And it's about how you bring that into your organization in the right kind of way. Rushing at the technology too quickly actually hinders you, because it does require some planning. And I'm sure everybody has heard the phrase, data is the new oil. And
Yes.
Actually, lots of people think that data is a value and oil is a value, ergo they are the same. Well, actually, the origins of that statement are because oil is a liquid and data has the same properties as a liquid. It is dynamic. It is changing shape all of the time. It is fluid. We are creating more and more of it. So, and if you have a well, an oil reserve, you had to spend some time finding it. Once you found it, you then got to build an oil rig on top of it to drill down to it, to extract it. And then you've got to get it from the oil rig to a refinery to turn it into something that is useful. Exactly the same thing from a data perspective. You've got to find your reserves, you've got to extract it, you've got to refine it to find the value in it, and then turn it into something useful. And because we are generating more and more data every single day, we have to use more and more advanced techniques to find the value in that data. And that's why I like the analogy of data is the new oil. Where it starts to fall down is we have a limited amount of oil. We have an infinite amount of data. And oil can only be transformed into a limited number of ways. We have a nearly limitless number of ways that we can transform the data that we have into ways that we can really extract value from it.
Wow, that's a really interesting analogy. I've never thought of it like that before, but it makes perfect sense. So what you're in essence saying is that we found a new renewable oil.
Well, yes, potentially for the future.
Maybe not the marketing message you want in the association, but yeah, no, really cool. So so AI versus generative AI, then, just to kind of focus on that part. What are the key differences?
Yeah, so if you think about artificial intelligence, is about using an algorithmically driven technique to find hidden patterns inside data. Generative AI is about the creation of digital assets. So really, they're trying to achieve two different things. So really, when you want to bring in an AI technique, you have an existing pool of data. Have a rough idea of how it's structured, and you can train an algorithm to find hidden patterns for you. When it comes to generative AI, that is about creation of digital assets. The most common is, and the ones that organizations are most readily adopting, is large language models. So these are comprehensive AI techniques that are capable of creating language. That's right. That's creative, capable of using language to create words in sequences, sentences that make sense. Creation of languages, I think, is probably the wrong way of describing it, isn't it? Creation of a completely new language.
Potentially. Okay, so if you wouldn't mind, put that into an example for us. So if you were to take, let's take ChatGPT, because I think everyone is familiar now with that. And that's a large language model.
Yes.
That allows you to ask a question, and that's going to go into the engine, if you like, and that is going to provide you the answers. But it's providing the answers based on what it's predicting. Is that correct? On on the data it's being trained on in the first place to create that kind of brain behind the scenes, if you like. The user, so you and I, are now communicating, we're talking to that brain, and it's predicting the answer based on what it's learned. Is that correct?
Yes, I've written. I'll send you it. I've written a quite a comprehensive blog that explains exactly how large language models work for anyone who wants the detail. But if you think about it this way, so GPT stands for Generative Pre-trained Transformer. So transformer-based artificial neural networks were actually developed, I think, in 2017. I think they went generative in 2018. So to give you an idea, the technology has been around for a while, but obviously launching of a public-facing entity that everyone could interact with obviously didn't happen for many years after that. Everyone has heard of ChatGPT, I'm assuming. Not everybody has heard of all of the other large language models that are available to use. So the way that a generative pre-trained transformer works is it takes the words that you've typed to your question and it turns them into tokens, which are mathematical representations of the words that you've used, and it puts that into the model. And what the model then does is it predicts the next most likely word in the sequence. Then it takes your original question, the next word that you've generated in the sequence, and puts that back into the model to generate the next word. So it's using its understanding of language and probabilistic mathematics to work out which word is next in the sequence. So it is creating its response a word at a time. And you'll see that if you use ChatGPT as an example, because it will spit out words and then it will pause for a bit and then it will spit out some more words. That's because of the way that it's processing the tokens that it is generating. What has happened with the very, very large language models is they have knowledge trained into them. And you can ask your favorite large language model when its training cutoff point was, and it will probably tell you. So some of the challenges that we see in the using things like ChatGPT are, one, they have a training cutoff point. So highly topical for anyone who looks at the date of this. If you were to ask ChatGPT what the result of the football last night was, it won't know because it doesn't have that knowledge trained into it. And secondly, generative AI is about the creation of digital assets. By its very nature, creation has ambiguity in it, and large language models suffer from something called hallucination, which means they make things up because they're using probabilistic techniques to work out the next most logical word in a sequence, and that may or may not be correct. So all language models suffer from hallucination, and there is a percentage probability that everything that you get from it might be wrong, which is why when you use a publicly available large language model, you have to fact check.
Got it. Okay, so that's interesting. So how does an organization then bring that into their business? If there is a kind of cutoff date on the data, and they're relying on accuracy to make decisions, maybe it's an insurance company, maybe it's a bank or something, how can they have the confidence and bring that in then?
So the latest thinking in the large language model space is to use something called Retrieval-Augmented Generation. You might hear the term RAG. Retrieval-Augmented Generation is what it stands for. So with this model, what you say is, I don't train knowledge into the large language model because that is extremely computationally intensive. So what can I do? Well, I can take my corporate data and I can put it into a knowledge store. But in retrieval augmented generation, the knowledge store doesn't speak a language. So I need an entity that is going to allow people to have a conversational relationship and take the response from the knowledge store and turn it back into a language. So I oversimplify a little bit, but for ease of explanation. So imagine that you ask your large language model a question. The large language model speaks the language of the knowledge store.
Mhm.
And when the knowledge store responds, the large language model turns that back into a language that we can understand. So in that scenario, what I can do is, because my knowledge store also has the place that the knowledge store got the originating data from in the first place, I can get that explainability. So if I were to contextualize that, so you ask a question in text and the response comes back with hyperlinks. So links underneath it that you can click on that will take you to the document that that piece of knowledge originated from, allowing you to do that onward fact checking. So explainability.
Got it.
And this is, oh, sorry.
Yeah, so I was just going to say, so presumably then, because a company doesn't stand still. There's always going to be new knowledge. There's always going to be new data. So
yes, exactly.
if I'm understanding this right, with RAG, they are continually uploading and updating the knowledge store, and
Yes.
then the RAG service is able to pull from that knowledge store in real time.
Exactly. So updating the knowledge store is significantly lower in computational intensity than training knowledge into a large language model. And there are a significant number of large language models available that you can get under what's known as an Apache 2 license. So that's open source. So you can bring in a large language model that another organization has built. You can then use open source technology to create your knowledge store, officially called a vector database, and you can use existing techniques that are actually using AI algorithms to take your data and put it into the knowledge store for you. So as a result, and what you really get with retrieval augmented generation is significant amounts of control that you might not know that you don't have if you're using a public facing large language model. So for example, the question that you ask a public facing large language model might not be the actual question that the large language model gets.
Mm-hmm.
Because there will be something called prompting involved in that, and they can change your question to have it have a different interaction. And secondly, if you have a corporate system that you've deployed on-prem, that you are using to have a conversational relationship with significant amounts of unstructured data, you probably don't want it to talk about politics or provide opinions about people in your organization. You can do that by implementing guardrails. So you can take your organizational policies and you can implement it as guardrails around your large language model. So you can control the types of prompts that it gets and the guardrails that are in place. So guardrails, as I said, to protect you from that, but also it means you can control the sequence. So let's say you want to ask it a question about a certain sequence of events. You can use guardrails as a way of making sure that the large language model responds with the appropriate sequence of steps. Instead of saying, do step 3, then step 2, then step 1, it will say, do step 1, do step 2, do step 3. Those guardrails and the prompting, you don't have control over when you use a public-facing large language model. If you're using it, if you're just exploiting the API, you'll probably only have access to things like model temperature, which is how weird and wacky the responses are going to get, and something called top K, which is the number of candidate responses that the model will provide you. So you've got a very limited amount of control. Using retrieval augmented generation, or RAG, you can completely control about how you implement it, how your data is exposed to your users, and the controls that you can put around it, as well as providing the explainability of how the response was posed back to the originator.
Wow. Okay. Fascinating. This is blowing my mind a little bit. So, would it be possible to have some sort of hybrid? So, if I was to use an example, Bloomberg, huge financial institution around the world. I believe they were one of the early adopters of this technology, in rolling out this technology, and they launched Bloomberg GPT. Right. So
Yep.
this allowed all of their traders staff around the world to be able to use natural language, so to be able to pull results or pull information, right? So a ChatGPT of sorts, but dedicated to Bloomberg information. But way I could see that is they would have a knowledge store. There's got a lot of kind of internal information, old data, current data, future predictions, or something along those lines that they would have within their kind of own knowledge store. But at the same time, there's probably information from outside their knowledge store, the kind of general sentiment across kind of market and from other sources of data, etc., they might need to get. So is it possible to have a system that kind of has that kind of hybrid approach, or are they kept kind of separate and presented as two different information points back, or two different services back to the user?
So I think there's a few architectural decisions you'd need to make in that. So we, for example, at HPE, we have something called Project Ethan, which is our approach. So we have Chat HPE, and with Project Ethan, it's a modular approach that allows you to choose the guardrails that you want to deploy. It allows you to choose the large language model that you want to use, and by taking that modular approach, it means that you can have different models that you can use at any time. One of the things that we are seeing is organizations who do want those specific capabilities normally will display the results from each large language model separately. One of the challenges is because of the way that they operate, you will get the complete response from one large language model. What you could do is take the responses from all your large language models, put it into another large language model, and get it to provide an overall summary across the responses. The challenge we see there is we have to bear in mind that it is computationally intensive to run large language models, and as a result, taking that approach, that obviously there is going to be a computational cost associated with standing them up in multiple instances. So normally what we'll see is a limited number of options that are then presented to the user to make their decision about which one of the two responses they think is most accurate. Normally that plays a more significant role during model selection, because you've got a significant number of models that you need to choose from. So as a result, you will use that approach of interacting with multiple large language models to work out which one is best fit for you and your data, meaning that it becomes an architectural point. But building a retrieval augmented generation system that is modular, that allows you to swap in and swap out your large language models, gives you the greatest flexibility, because we are seeing it is still having the tick-tock between large language models being updated is actually quite small. So if you embed too much with one large language model and then another one comes along that is better, engineering one out and engineering another one in can be an investment when it comes to developer time. So applying a modular approach is really where we're seeing organizations go, especially during the dev and test life cycle, to help them do model evaluation.
Brilliant. Okay, and let's pick up actually on that computational intensity. So even though there are ways, as you've just described, to be able to kind of optimize that, because there's a big infrastructure cost that's associated to it, and an energy impact as well, right? In terms of this stuff consumes a lot of electricity. We've talked about it before on the CUDOS Cast. That puts stress on the grids, puts stress on the environment and stuff like that. So, we talked about how you can put efficiencies in, but it still needs an incredible amount of infrastructure, and that's kind of where HP is at the forefront of that. So, these brains, if I want to kind of simplify things, these brains are calculating trillions upon trillions of different possibilities on a kind of per second basis. Is that kind of accurate?
So probably the easiest way so yes, they will be doing billions and billions of computational activities. When it comes to identifying the word, they'll be using something called a beam search, which is how they narrow in the selection criteria, and then this thing called top K, which produces a candidate list of words, and then they'll be using a mathematical technique to work out which word is the most relevant based on the input sentence that was provided.
Mm-hmm.
When it comes to computation intensity, really it's about sizing or making decisions on the infrastructure that you need to provide, because it's based on model size, because you need to run them inside memory on the accelerator, which would be a GPU. So looking at GPU memory, sizing of models, and as a result, that will influence the type of GPUs that you're going to select. So at HPE, we have recently done our Discover, and at Discover we announced Private Cloud AI, which comes in small, medium, large, and extra large, specifically around your decisions about what you want to do from a retrieval augmented generation perspective. So as a result, we've made it extremely easy to deploy. So you can bring retrieval augmented generation into your organization with a pre-configured infrastructure and make some decisions about whether or not you want to go from small up to extra large. And that's kind of unique in the market at the minute in terms of what we're bringing around that ability with a very simple deployment configuration, get you up and running from a RAG perspective.
Wow. So, I mean, you said right at the beginning of the CUDOS Cast as well that the GPU is really the leap in technology here that's kind of accelerated all of this. Now we've seen those kind of release cycles get shorter and shorter, and as the efficiencies, as the power from these GPUs, as the amount of calculations that they can do increases kind of exponentially, really. So how does a huge corporate company like HPE that is having to build the server solutions and the services that surround that keep up with the speed of innovation and delivery of these new graphics cards?
So it's a couple of things that a lot of people probably won't know. So HPE has had an AI center of excellence for more than 30 years.
Okay.
So for us, this is definitely not new technology.
Been practicing for a while.
Yeah. So we created, I think, our first NVIDIA Center of Excellence was created in 2013.
Okay.
So so we've got extremely deep relationships with NVIDIA. We also have great relationships with all of the organizations that do GPU acceleration. At Discover, Antonio stood on stage with Jensen, just to demonstrate how deep our relationship is with NVIDIA, and they are the predominant player in the AI space. Other options are available.
Yeah, I was going to say this again, BBC. I could feel that,
Yeah. So, but it is about from our perspective, having deep relationships, sharing roadmaps, co-engineering, co-development that allows us to keep up with the evolution in the GPU space. We've got like 300 patents or more specifically around direct liquid cooling, so which we're starting to see an increasing role as GPUs have more and more power requirements. They're generating more heat, so you've got to keep them cool. How they interact, how you make sure that you can schedule them correctly. Where it starts to get really interesting is the software layers that you need to live on top of the GPUs. I mean, all of the GPU vendors are working extensively on their software stack, because a GPU card in its own right needs the right kind of libraries, the right kind of frameworks, the right kind of management capabilities that live around it that really allow you to squeeze every ounce of value out of it. And if you start to use pre-trained models and start to think about, sorry to get technical, like the floating point precision associated with those models, you can reduce the model size, and which means that ultimately you can reduce the computational power needed to run those models. To do that, you need a comprehensive set of tools that know exactly how to tune your models specifically for the GPUs. So really the innovation, the pace of innovation is happening in the software space as well as in the physical hardware. So from our perspective, we've got a comprehensive software portfolio specifically around AI to drive to shorten the length of time it takes to get models operational, as well as working with the GPU organizations who have that capability to reduce or, well, increase productivity when you're using the GPUs. And really, that's where we've been working. So not only on the hardware side, but also the software side. And then we have a comprehensive set of services as well that live in the AI space to help organizations get up and running, to build models, to tune models, to deploy models, all of which has a very specific skill set associated with it, which we know is in pretty short supply at the minute.
Brilliant. Wow. Well, Matt, it's been absolutely fascinating talking to you, and I feel like we could probably chat for another 3 hours, but we are going to have to wrap it up at some point. So before we do, any kind of final thoughts? How do you see this playing out? Where do we go? Where are we 5 years from now?
So if I were to play it out 5 years, I think some of the big things that are going to happen in the AI space, one is something called synthetic data, which is using large language models to create data that we might not readily be able to create. So when it comes to accelerated drug discovery, we can create things that we might not necessarily be able to find ourselves. I think that's going to play a very significant role in how we drive AI initiatives. So we can use generative AI to create training sets for use by more traditional AI techniques. There's a risk associated with that, which is something called model collapse and catastrophic forgetting. We could probably do a whole new episode on that, but definitely a big area of research. The other one is microservices. So where we're starting to see how multiple AIs can play a role in decision making. And a lot of this is coming out of some of the advanced robotics world and autonomous driving, where I have some simple AIs working with some extremely complicated AIs in order to tackle really significant problems. And that comes in the form of having a collection of microservices that are going to run. And as a result, I can have lots of AI models that are collaborating together to provide ultimately a better answer. And that's really where we're starting to go. Retrieval-Augmented Generation, I think, is going to be definitely, it's the latest thinking in the large language model space. And I think that is going to get more significant, and that is going to democratize data, because instead of needing to be a computer scientist, you understand how to build SQL queries and all this other kind of stuff. It will allow people to have much more conversational relationships with not only their data, but also their IT infrastructure.
Brilliant. Matt, it's been an absolute pleasure having you on the CUDOS Cast today. I want to thank you from our audience as well, because I know that they're going to be fascinated in listening to this and play back. So thank you very much for joining us. And for everyone that is listening, this has been the CUDOS Cast, and looking forward to the next one. So, yep, once again, CUDOS Cast, it's been a blast. Thank you.
Thank you.